Hello everybody, today we're going to do some reverse engineering again because I just came from work and I'm completely down. I'm so tired and now this sounds very stupid, but basically I've been reverse engineering the entire day at work. Some existing application and I wanted to figure out how to set it up and configure it properly. It had to do with some spacecraft stuff, but now I'm really done with all of that stuff and I want to reverse engineer something for fun myself. Something that I have control over, where there's no stakeholder, no customer, nobody waiting for results, just me with some basic hacking stuff. All right, so let's cd into the crackme directory. I've already downloaded the file. This was the zip file. I unzipped it and compiled it. If you want to know where that's coming from crackme.1, and it was the XORcist crackme here. It already comes with an executable binary, but it didn't execute on my system, so I had to compile it again. And conveniently, very conveniently, this zip file already has this compile script, so we know exactly what we need to compile. Basically, it's just GCC with the -s flag specifying the output. I just want to look up what the -s is. Let's see. Probably it's suppressing something. Oh, there's a lot of options here. Maybe let's look up the help. Capital S is compile only, but we had a lowercase s. I have no idea what the -s flag is. What is it? GCC-S. Remove all symbol, table, and relocation information from the executable. Okay, so that makes the executable smaller, I think, and removes information from the executable such that we have a harder time reverse engineering it. This package also comes with the source code in case you need to compile it yourself, but the point of it all is that you don't peek at the source code yourself. You just use it to compile with the compile script and then you remove the source code. And now we are left with the executable. So let's have a look at what it does. What's the password? Well, what is the password? Let's try something. Password. And it says nuh-uh. So that's not the password. Let's try something again. A very common one is hex or that's not it either. And let's try 1, 2, 3, 4, 5, 6. And that's not it either. Let's do a very stupid check and just open the file in Vim. I know it doesn't make sense because it's all compiled. And this is not useful at all. We can open that file in GDB in the debugger and run it there, but here I already tested it before and it says starting program, no la polizia. And that is, apparently it has a debug protection built in that prevents this executable from being executed, from being run inside a debugger. If we do layout next, we can still see the assembly code, which means that if you can read assembly, then you can probably already do something with this. I can't read assembly. I know that this is a move command. It's moving information or copying it into this register from this register. But I really can't make any sense of the logic here. What looks suspicious is this hex string. It looks quite arbitrary. Anything that looks arbitrary is, well, there's a chance for any arbitrary looking information here that this is the password. But this could also be a memory address, an offset, who knows what. It could be a false flag, some wrong information that is just there to mislead us. So I will not attempt to try to understand the assembly code because I'm not crazy. At least I'm not crazy enough yet. If you want to read that assembly code, please do so, try it, stop the video, download the executable, and try to understand the assembly code. But I'm not going to do that. We're going to do a cleverer way. Let's open the Explorer and check out the files here. Those are the files in my Windows system. As you can see, we have the zip file, the compile file, and the XORcist binary. And I will put that into a decompiler online. So let's move that file into this decompiler. And then it's already decompiling something. And now we have the decompiled source code here. Of course, it's not entirely clear text. We do see function declarations. We do see methods. In C there are only functions. We do see variable declarations, variable names, argument names, but they are all meaningless because they are just named according to their type or somehow arbitrarily. So they are not very helpful. Maybe let's see. So the Ghidra one is not decompiling for some reason, or it's taking longer than the others. I will copy the BinaryNinja one. To get it, just highlight it all, copy, and let's go back into the crackme directory. And let's create a file, decompiled.c, and add all of the source code. And there we go. So let's try to find something that where we can find a grip, where we can start orienting ourselves. All of those methods here, they look like they just set a variable and then return. They just look like a labyrinth. They don't look like they are actually doing any of the logic. I don't know what the tail call comments are. They seem to be, all those methods here seem to be wrapper methods around syscall methods. Yeah, so there's an srand method here and calls srand in, I think, in the operating system. I don't know. Let's see. There's a start method, but I can't see any logic here. There's here. This is the logic. But where's the message that we saw earlier? Oh, here it is. What's the password? it was asking us for the password. And this is the main method. So this is clear text. So what is the password? Is put to the console. Why is it using puts? I think that's put string, or that puts a line to the console. Yeah, accepts the string and then feeds that into the syscall puts method. And then fgets is used to write into a buffer 0x20 standard in. So maybe we should look up the documentation for fgets. I think it's just getting a line from a file stream. I just don't know what the 3 expected input arguments are. So here's the method prototype, and it expects a character string, an integer size, and a file stream. Okay, so it's expecting 0x20 number of characters from standard input. 0x20, by the way. Let's go into the Python shell over here. I think it can help us converting between hex and decimal numbers if we just type the hex numbers here, and then it gives us as a return value the decimal number. Well, of course, this is 32 because this is 2 times 16 plus 0 times 15, I think. No, plus 0 times 1. All right. So fgets reads 32 characters from standard in into the buffer. And then the buffer is accessed at a specific index. I don't know what. This is probably the last index, because here it's trying to get the string, maybe character span of the buffer at the new line. So the last character of the buffer, and the last character of the buffer is set to null. I think this is for null terminating the string. Or 0, depending on how you pronounce that. Then a random number is generated. I don't know how that's useful. Let's see where we can get a success message. Here's the NAA, which rejects our login. And here's the printf, which says that we are logged in. We are logged in as someone. I don't know if this variable 64 is important. Let's look up the crackmes.1 page. And here it says easy crack me with control flow obfuscation. Okay. XOR encryption and anti-debugging. Can you get the password or patch the validator function? Oh, so we can also patch the validator function. Does that mean that we can just... I think that means we can rewrite this source code in a way such that it allows us to log in. But of course, it would be more interesting to get the password. I mean, in practice, it doesn't matter whether you get a password to a protected system or whether you patch it and get access that way. Doesn't matter at all, but I find it is a more elegant solution. So what is the password? Here, this is quite confusing. There's this if clause, and if this if clause succeeds, if this if clause succeeds, well, no, if this if clause succeeds, then we are not allowed to enter. And if it doesn't succeed, then we are allowed to enter. What does that mean? This, correct me by the way, has a difficulty of 1.7, so it should be fairly easy. The difficult part is only that you have to find a starting point always. So what is the starting point here? Maybe let's have a look at what this var50_1 method does with our input buffer. The input buffer, just to keep it in mind, is the input which we entered here for the password. And there's an interesting point. fgets reads hex 20, so decimal 32 characters into the buffer, but the buffer can actually hold more than that. I don't know if the fgets actually terminates once that length is reached. It should probably. Yeah, fgets reads in at most one less than size characters from stream. Reading stops after an end of line or a new line. Okay. So what is really happening? Let's rename the buffer. I think there's just one buff variable. So we can safely rename everything that is called buffer in here. Ah no, there's another one as well. That makes it more confusing. Okay, I will highlight the main method and go down to the end of it. And inside that method, inside that range, I will rename all occurrences of buffer input buffer, just so it's more clear. Oops, wait, let me try again. I highlight all the contents of the main method and then do a string replace buffer input buffer -g, and it replaced the input buffer 5 times. Okay, so this is our input buffer. Wait, if we are more clever than the system, and or if we interpret the rules in a way that well, okay, the executable has anti-debugging, but we have decompiled the source code. Can we now just compile that again with debug flags? How about that? So what happens if I do gcc-g decompiled.c output decompiled? Doesn't work, of course, because there are a couple of types and inputs that are not clear to the system, I might have to import some libraries or make them visible. The other, this one has an input.h file. Wait, what is Ghidra's output? It includes out.h. I don't know what that is. Okay, so the decompilers don't know what the included header files are. What we can do is we can just do some clever guesses and include standard.io.h. Then we include standardlib.h. Then we include string.h. Then we include strings.h. I don't know what else there is, honestly. But this looks now fairly clear to me. Let's try to compile this again. We still have a couple of errors where there's an occurrence of __ pure. I don't know what that is. And then there are a couple of syntax errors, it seems. File is defined in header standard.io.h. Did you forget to include standard.io.h? No, I included standard.io.h. It's the first include statement. Okay, maybe compiling this is not the best idea right now because there seem to be errors that I can't fix right now. Some things here I can probably just remove. I mean, they look totally superfluous to me. Those things I can also remove. String, time method, fgets, fopen. They are all part of the standard libraries. Even rand. The start method, I don't know. I think I can remove it. I think I can remove that one as well, and that one. And all of those. This one I don't know because it contains a specified file path. Is it called somewhere? Yes, it is. It tries to open a file. Proc self status. What is that file? Okay, we're going to do the following. Let's read proc self status. And this contains the status of the computer hardware, CPUs allowed list. Interesting. But this is a while true loop. So this is probably the trap for the debugger. This is probably the anti-debugger. Right. Oh, did I save it? Yes. Let me show you. Let's execute the application with the debugger, XORcist, and let's run. It exited with code 01. La Polizia. Oh no. So basically this is reading this status file, a status file stream. And if the file is accessible, it's stuck in this while true loop, reading strings from this file, tracing things here. No, I don't know what this is actually for. Something must be the trap for the debugger. So I thought it's this one. But what if this file pointer is not in use, then what happens then? No idea. Let's just delete all of that. It's probably not important. It's probably more confusing. I find this quite hard to read, and I don't know where to start making this more readable. So maybe let me try to start from a clean file again. Here's our decompiled code. Maybe let's use Ghidra this time. Maybe it contains something that we can grasp. And there should be somewhere in here, what's the password? Then it gets from local 38. What's local 38? That's that's now a character buffer of length 40. That's the one that I showed you earlier. So this is the input buffer. Here it's a bit different. This is way more readable, by the way, because this is not storing all the data as hex. So now this condition here looks way easier than the other one. So Ghidra took longer to Took longer to compile or decompile, but the information it puts out is maybe even better than the other one, than HexNinja. So let's start with renaming the local 38. Local 38. And let's call it input. Let's just call it input string. So we have this input string. Then what else do we have? After this input string, there's immediately the local 10. What happens with this? Local 10 is what's that syntax? This double dereference. No, it's the dereferenced long pointer this. And the in-fs offset is probably, this is probably some base pointer. I don't know exactly. But it's looking suspicious because there's this in-fs offset. Wait. It's used in many places. Okay. It seems to be present in any method here. It's in every method. So this is probably a base pointer for the function's stack, I would assume. So where's my input buffer? Here it is. After that, we have this local 10, and it's the value at whatever's after the input string, and the hexadecimal 40 is the same as the decimal 40 is the same as the hexadecimal 28. And we can verify that in the Python console here. 28 is the decimal 40. Then let's go and check out what else we need. So this looks like we could overflow information into local 10. Buffer overflow is a classic, but it seems to not be used anywhere else. I don't know. Well, but for a buffer overflow, a variable doesn't need to be used, strictly speaking. So the if clause checks if I variable 2 is 0, and this is dereferenced local 50 and then input string. I don't know what that syntax is doing. Local 50 seems to be a function. Is that maybe a function called with the input string here? And then this returns a return value. Yeah, I think local 50 is a function pointer. So let's rename it. Local 50 is a magic function called with the input string. And ivar2 is, what is that? Is a random variable initially, but not later. Later it's just overwritten. But here it is a random value. I don't know if that's even meaningful in any way. What is this function doing? It's just... no idea. ivar2 is equal to 0, then nuh-uh, or ivar1 modulo 100 is equal to -1. This can never return -1. Nothing modulo anything is a negative number. So this is bullshit, I think. So we have to make ivar2 not 0, it seems. Let's have a look at what the magic function does. It's declared here using this code data type. What is code? I don't know, but we can look up the function. Let's not care about the code data type. So here's the function, and it expects a parameter, which is a character pointer. It does some things here and returns ivar1 equals 0. So this returns a Boolean value, true or false. And if it's true or false, is 0 true or false here? Let's look up bool. Then let's cd into user, include, and let's grab RLI for bool. And there's a ton of results here. Is there a file out.h? Because that's what Ghidra declares. No. Ah, it's a local.h file. Ah, of course, that's not very helpful. So here we print logged in as someone. As who? Maybe that's the wrong question to ask. We are logged in as this guy. Should we decipher this? Yes. Let's find out as who we're logged in. Maybe this already gives us a clue. Can we just check the ASCII value of a hex number like so? 114. No, this cannot be. Hex 72 is in ASCII values are probably hexor. What is 6F? Oh, yeah. 6F again. O. And 74. 74. T. T-O-O-R. Or no, it's root. R-O-O-T. So we are logged in as root. That will be the output. Logged in as, let's rename the local 64 to root string. So we are logged in as root string. Is this even used anywhere else? Not really. But undefined 4 could be a character pointer. I'm quite sure this is a character pointer. Is undefined 4 used anywhere else. Yes, so let's assume this is a... No, maybe it's a character array. Somehow I'm not progressing fast enough for my taste. So we're getting the input string here. We are finding the last index of the input string. We can rename the svar to last index. The input string at last index is set to the terminating 0 character. Then this ivar2 is a random variable. I don't know what this does, but it does some character arithmetic here. What is 0x5? 0x5f. It's an underscore. So what does this do? It's doing ivar2 plus ivar2 divided by 0x5f. So that's divided by 137 or 94. Which one is it? 94. Minus 94, no, multiplied with minus 94. So this is canceling out this division again. We can just cancel out the division here because this is now meaningless. And this is effectively doing ivar2 minus ivar2, which cancels out the ivar2s, which makes them completely useless and leaves us with a space character. That means local 3a is a space character. Local 3a is a space character. Let's replace it everywhere. Awesome. ivar2 therefore is completely useless and we don't need it. And we can call it useless confuser or something like this. Yeah, it's just... But it's still used in some places. In this case, right here, it's completely useless. At least it didn't affect the space character. Here it does something again with this method here. It is moduloed with 1b39. Probably that's 65,535. Let me guess. 1b. 39. No, 6969. What? Plus 1, 6970. No, the modulo comes before the plus 1. So what the hell does this function do? The input to this function is probably not doing much. If parameter 1 is 0x539, then bvar1 is true. Well, what is returned in the end? We don't need to care about what bvar1 is. So bvar1 is true, or it's false, or it's false, or it's 0x4d2, which is 0x4d2, 1, 2, 3, 5. 1, 2, 3, 4, 5. So maybe this function Maybe this function always returns 1, 2, 3, 4, 5. Because the input is always, as you know here, we have this output some number, and this is +1. This is a modulo odd number. If we modulo with an odd number, does that mean that, what does it mean? No, we can't say whether the input to the function will be odd or even. But we know that this will be a value between 1 and 6969 maybe, or 696. Yeah, it will be a value between 1 and 6969. This will be a value between 1 and 6969. That means if we go into this function here, if we modulo with, no, if we check whether this value is 539, let's see, 0x539, that's 1337. Oh, yeah, funny numbers here. Else if parameter 1 is, if parameter 1 modulo 0 is 0, modulo 7 is 0, it returns false. I don't get this function. This is just arbitrary confusion here. This is just a distractor. Yeah, but what the hell was I doing? And this function is not even returning anything, or it's not even setting a value. So we can comfortably just ignore this. Let's call this function. Let's call this function distractor function. So this is just a distractor function. It does nothing. We can comment it out. Then ivar2 in this case still doesn't do anything. What does ivar2 do in this magic function here? Does the magic function even do anything? This right here is the magic function. So let's jump to the next occurrence. And it copies a string into local 28. Local 28 is a string of length 24. Then it copies something into local 28, but does anything happen to local 28? Yes, this variable is called in another function compared with string compare maybe. And then in the end, ivar1 equals 0 is returned, which is the first, no, where is it declared? Here. So this function returns whether parameter 1, which is input to this function, is equal to local 28, and local 28 is equal to this data thing. But where is that coming from? That is coming from nowhere. Yeah, that is not declared anywhere. Did I mess anything up? Because I would expect at least that the decompiler outputs some coherent source code. But no, this variable really seems to be declared nowhere. Maybe we can have a look at another decompiler and see if we can make out what this means in another string copy call. Yeah, here's the data thing as well. It just has a different name, and it's not declared either. So this must be a fixed constant coming somewhere from the operating system libraries or system libraries. String compare. Yeah. So this is giving us a hard time. It's returning whether variable 1, whether a string is equal to another string. So whether the input string here, provided here, is equal to another string. What is the input string to the magic function? It's our input string that is put into ivar2. And if ivar2 is 0, then we get an else we get the logged in. So if ivar2, okay, so basically everything depends on the value of ivar2, because as we've already learned, ivar1 modulo 100 can never return -1. At least as far as I know. So I would like to comment this out because it's stupid, superfluous code. Let's have a look at ivar2 again. So the magic really seems to happen in the magic function, unfortunately. And I hate magic functions. Okay, so magic function is called with the input string. And magic function is this magic function. And here we are calling string copy of this date, of this dat thing, which is declared nowhere. And that doesn't make it easier, but there's another function call. So let's call this first magic function, let's call it magic function 1 for first layer, or let's call it first layer. Oops, let's rename it globally. Okay, so we have this magic function first layer here. Then there's another function call with the local 28, which with our string. So let's rename. I think this should be called string to be compared or string to be matched. And it's here. Yeah, so here there's a second string compare of parameter 1, which is the input to that function, and the string to be matched. So our input, which is also the password, the input password, has to match this string to be matched, and the string to be matched is input here into this function. So let's call parameter 1 in this range password. And let's check out what this magic function second layer does. And before we check that, let's rename that function. Magic function second layer. because it's one layer down from the original magic function. And here, here the magic function's second layer takes as input the string to be matched, which is a character array here. And here the input is a long. However, this is actually a character pointer. This is just an address, I think. So parameter 1 is still an address of a string. Yeah, it's still the string to be matched. So let's call the long parameter 1 also the string to be matched. Let's call it string to be matched, or string. Let's call it match string address. Okay, and now there's a, correct. Now this match string address is offset by local C and then dereferenced. So some character at that address is read, starting with 0. So it's looping over every individual character. So local C can be renamed. Local C can be renamed to character, or I can't name it char. Let's name it just C. Oh, it doesn't work. Because of the percentage, not applicable when we are replacing on a range. And undefined 4 is a character. Undefined 4 is a character we can replace in Word like this. So for character 0, while every character is not the terminating 0 character, we are incrementing by 1. And then the match string address, which is input here, is dereferenced to a byte from a byte pointer. Don't know why. It's doing something byte-wise. There's an XOR character, which is indicated. I think this might be the important place because this is called XORcist. So we are XORing the match string with 0xA9. We are XORing every single character in the match string with 0xA9, and that is 0xA9 is 169. What is that in binary? 0xA9. Wait. Hex to binary in Python. Bin. So bin of 0xA9. It's this number right here. And then the output of that XORing is written into the match strings. It's overriding the match strings characters here. Okay, that means something is being overwritten with this XOR, so it's obfuscated. Maybe we have to match the obfuscation somewhere. So we are obfuscating the string to be matched. The string to be matched is what? It's just this. It's just declared. And here we are string copying something into that string, whatever that is. String copy, string to be matched. Oh. And then we are comparing the password with the string to be matched. So the password must be the string to be matched. That's my understanding. String comp. Let's just look that up for a second, just to be sure that it's really a string comparison method. Yeah, compares two strings, returns an integer less than, equal to, or greater than 0. Okay. String compare. Oops. Password with the string to be matched. The string to be matched is this string. But what is the string? That's the entire question. It's the address of that. Let's look up what those structures or data types are in Ghidra. I'm missing the definitions of all the variables that. How to go to a function definition from that in Ghidra? That means the data type is undefined. Which makes it quite hard. We have to match the string inside this that object inside this that string and then that needs to be equal to the string to be matched. if the info is not present in the binary, then it can't be recovered. So are we comparing info that is not present in the binary and we have to figure out ourselves somehow? Is that really? No, this cannot be the case. Wait, I'm using my own compiled binary. What if I compare it with the binary that we would get from the original crackme? So let's make a new directory, original crackme, and move or copy the XORcist into the original crackme. I just decompiled my own crackme, my own compiled crackme. But there's also one supplied with this package here, so maybe this one contains better information that we can use. So I know this is the source code here. This would be cheating, so let's remove it. Or would it be cheating if there's the source code? Yeah, I think it's just for convenience here to be able to compile the binary yourself. So let's upload this file to our decompiler and see if it has any additional information. I don't know if it already decompiled it so fast. Let's wait for the Ghidra output. Or if it's too slow, let's get the BinaryNinja one. 1 second. Needed to turn on the lights. It's better now. And while it's decompiling, let me write to my girlfriend that I'm still alive, because she's probably sending me messages. Ah no, she's just sending me reels on Instagram. Because sometimes when I'm recording, I'm plainly gone for 2 hours at a time or 3 hours for long videos. And people worry. But I'm doing important stuff here, decompiling. And then in the evening, I'm regretting wasting my entire day working and then reverse engineering stuff. But that's how life goes. I find this is, I think I already said this in some video, but I find all this technical stuff weirdly satisfying for my brain, even though it's draining. I really like it. I hate this challenge right now somehow, and it's bugging me. But once it's done, the feeling is so awesome, and that's actually the entire reason why I'm doing it. Okay, it seems that Ghidra is taking quite some time, so let me just get the BinaryNinja one and see if we can get the string copy command from there. Decompiled original. Let's create a file, decomp original C. And here we have where's the magic method? I think it's this one. Yeah, that looks suspicious. That looks like it. And then there's the layer 2 function in here. Yeah, and here this XORs everything with the 0xA9. But there's no data fields in here as for the other string copy method. Let me create a new tab in Vim here to have both in the same editor. I just have to save this one. Tab E. There it is. Edit anyways. Okay, I'm going down. Where's our subroutine with the XOR? Let's search for the XOR. Search for this. There it is. So this is taking as input a string or a void buffer, but this is likely the string. And then for every character in the string, yeah, the result is being XOR'd. No, the result is checked whether it's the 0 character at the end. And this right here says or makes the characters in the wait. No, this returns the result. The result is just a string. Ah no, but this actually writes stuff into the memory. So yeah, this overwrites the provided string. The result is the decompiled at the dereferenced. What? I don't get the return value here. Because here we are looping over argument 1, the input, and adding increments of characters here. So characters growing. And at some point, result will be the last character in the string. And then that while loop will be terminated and result will contain the last. It will contain 0. So I don't get this. Is this correct? arg1 plus var c. XOR'd with 0xA9. arg1 plus var underscore c. So the character at that address is XOR'd. Then the result is returned and the result will be meaningless. Yeah, the result is not used here. The result is just meaningless. It's just the 0 character at the end, I think, or the last character. No, I think it's the 0 character at the end. So the result is not used, but the input is XOR'd with 0xA9. And then this string comparison checks whether the password matches the string to be matched. And the string to be matched is this data thing here. So we have to find the string to be matched. And what is it here? The string to be matched is variable 28. So it's this. And here this is referencing the data. And it doesn't exist in this string copy thing. Well, not in the string copy thing. It doesn't exist in the source code declarations. This data, where is the taking from? So this string var28, or in this case, the string to be matched, the string to be matched is put into the magic function second layer and XORed with 0xA9. What if the string to be matched is zeroed out? That would mean if this string to be matched is zeroed out, then after this function call, it's 24 characters XORed with 0x49. No, 0xA9, I mean. And 0xA9 is this. And and 0xA9 XORed with 0 is 169. And as a hex value, that is plain and simple 0xA9. In ASCII characters, 169 or 0xA9 A9, where is A9? There's no A9 here. So if this is 0, if this is simply zeros, then 0xA9 would result in ASCII character 0xA9, which would result in a character outside of the range of ASCII characters, unfortunately. Let's see, are there any hints on this side here? The password is encrypted by a simple XOR shift. Yeah, that is completely fine. The password is encrypted by a simple XOR shift, but however, the problem is we don't know what is XOR shifted because the password is stored at this dead object. The DATs are referencing places in memory where data is or will be located. As such, that function may be the only place in the program that reads writes to those locations. Or other functions may utilize them as well. Maybe that is just zeros, but that cannot be. Well, it can be, but it's unlikely because that would mean that our ASCII character is outside of range. What if we 0xA9 with FF, with 0xFF, then we get 86, and 86 is inside of range. It's a V. It's very, very unlikely that the password is 24 Vs. So there's for sure data inside this. I just can't find it. Okay, I just had to ask ChatGPT because I didn't find anything online here, and I want to waste nobody's time and still keep everybody learning. So it answered that in Ghidra, that is just an address to a memory location inside the binary, and the data is located at this address inside the binary. So what we have to do is we have to object dump this binary. So let's try that here. Object dump -s. Right. We have to use -s, -j. Let's look up what those are. -s. A specific. Okay. We want to display information for a specific section, which is the -j, and the -s is full contents of all sections requested. Apparently it truncates the output somehow. Now we have to object dump -s-j the section .row data. Let's look up what that is. Row data section. Yeah, here. So how does row data occupy ROM space? And row data is part of the program here. This is what a typical executable looks like. And when you add the const keyword, the array gets moved, or an array would get moved from the data section into the row data. The net change in file size is 0. If you add a static keyword to your array, it will be moved into the text section. So there are different sections for storing different kinds of data in binaries, in object files. That sounds like something I should read up on a bit. Quite interesting. But let's close it and keep it practical. Let's object dump the row data. And the binary name is XORcist. No, we have to do it in this directory because I want to work with my compiled XORcist. Object dump -s-j .row data XORcist, and then let's pipe that into less. And here we get the output. And here are all the constants that are used. No, la policia, what's the password, logged in as something, something, So those are the constant data fields. Okay. And I would expect that somewhere there's my data field, and it looks like this would be the address. It's located at address 0x00102023. 0x 0102. Let's look for that. 0102. Pattern not found. So I think I understand the output of the object dump now. So basically, this right here are the addresses. And those are the contents of the memory. Those are the values. And those are translated ASCII representations of that memory here. And the row data section encapsulates everything that ends with 2000, and our memory ends or starts at 2023. So we would have to look up 20 here, 2020. Then, as you can see, there are two characters from this tracer PID string, 1, 2. So this is 2021, 2022. And then this should be the start of this data section here. And I would expect it to be 24 characters. So let's copy those characters here to 0 to 3. So this is, I think this is the first character, D. Let's confirm by looking up 64 in ASCII. Let's man ASCII here, 64. And where is it? Oh no, this is an add character. So how is this translated to a... this is a hexadecimal 64. This is not a decimal. So the hexadecimal 64 is this one right here, and it is indeed a D. That means that we have to look up 00DD. We have to look up 24 characters starting from the 00. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Those are the first 14 characters. Let me just copy them and let's paste them somewhere. That contains this 15, 16, 17, 18, 19, 20, 28, oh my god, I counted 28 after 20. I really need a break, guys. It's really late already, and I had no break today. Okay, let's try again. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so let's copy those as well. Let's go to the source code where we pasted our data. And now we just need to translate, we need to XOR this data. And then we should be able to get the password. So let's XOR starting from this 00. So we need to have a function that XORs this and then creates an ASCII character from that as XOR. Python ASCII from hex. Oh, and there's a complete decode function. So that's useful. We can just XOR all of those first. I don't know if that's the most efficient way, but I'll do it. XOR 0x49, no, A9 is 169, and then the hex value of that is this. Yeah. So let me just drag the XORed value here, A9. Then DD. Of course, it must be 0xDD. And we can get, 74. DA 73. F6 0x5F. D9 70. C4 60. C6 0x6F. F6 CE 76. C7 6E. CE 76 and C7. Almost there. Then CE again is 6, 7. F6 again is 5F. C0, we didn't have that one before. 6, 9. CA is 6, 3. C5 is 6C. Then 0, 0 is A9 again. 4E. 0x. E7. 6F. We had this one before. I think. C6. And then 6F a couple of times. C6, 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 C6. What is that last F here? Ah, yeah. So do I have enough C6s? C6, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, C6. Let's save that. And let's convert that thing to a string. Decode hex. Decode hex. What do you mean decode? Ah, Python 2 only, of course. Oh god. Decode hex uses bin ASCII unhexlify. Codex decode works for Python 2 and 3, but it returns a bytes string in Python. but that's reasonable for an ASCII string. Byte array from hex decode. Okay. Byte array from hex. Oh, no. Decode. Doesn't work. String object has no UTF-8 codec can't decode byte 0xA9. Yeah, because it's not UTF-8. I want ASCII. Decode encoding ASCII. So let's pass that as an input. Doesn't work. So maybe this is this is just the zero. This was just the zero terminating character from this string here. So this is not part. I think I would start with the one after that. Not sure. Let's try and let's just remove this A9 first. Why is it still complaining? There's again an A9 in position 16. Yeah, maybe, that's the zero character from that string. And then the C6s, they just indicate that the memory was initialized with C6s or with the XORed version from that. So I think this should be the string. And this right here is the password. That's also the thing that the one guy in the hints wrote, I think. But I didn't understand that as a password. Anyways, it's great that we have something that could be the solution. So let's clear the screen. Let's call XORcist. What's the password? And let's put in, not that one. Let's put in ts_pmo_gnng_ICL. I honestly understand nothing here, so if this contains any references, please let me know, and let's try and see if this is the real password and whether we succeeded reverse engineering this executable. Let's go. No. Do we have to reverse this string maybe? Wait, let's look up the underscores. 74, 73, 5F. Are they really underscores? 5F. Where's 5F? There it is, underscore. Maybe I have to write this in reverse. Depends on how this is stored in memory. I have no idea. So let's try. LCI GNGNG underscore OMP underscore ST. No. But this must be the password. Maybe I messed up somewhere. Do I have the correct extract from the object dump? Where's the object dump command? There it is. So we start. Do we start with the 0 or with the DD? It's very likely that this is actually our last character, and then all of this is reversed until we encounter this 6F here. Maybe I messed up somewhere in my manual translation. That's always the downside when doing manual translations, of course. So let's try to write down everything again. Let's align it with the thing above. And then what do we do as the next step? Let's align this one with the above as well, removing A9. And then this ends at wait. It can't be that hard. This right here is the password XORed. Python XOR hex string. You have the strings in encoded form. You need to decode them first. Okay, this is binary A. Okay, then let's try something. This is the XORed password. XORed password is equal to, and then we decode this, all of this, using the hex decoder. Doesn't work. Attribute error string object has no attribute decode. Yeah, we have to use Python 2 for those things at least. We had this in the past already. Python 2, do I have Python 2? Yes, I have Python 2. Then let's just use Python 2. Decode hex. So this returns TS, PMO, GNG, and GNICL. Ah, no, but we have to decode this one up here. So, hexed. No. How do I call it? XORed original is equal to this string. Let me just manually remove the white spaces. And then decode hex. If I print that to the console, what happens? We get something. Then I XOR it. Then I XOR every character with 0x49. So let's do that. Python loop over characters in string. For character in string. Okay. For wait. Let's call the first hex string, and store it in a string variable. I don't think we can use it, but let's do it anyways. Then XORed original contains, what does it contain? What is the data type here? Type XORed original is a string. For C in XORed original, print C. Let's see what happens. Oh God. I think it's even faster to do it manually again. So let me remove the white spaces here. And let's try again. So this is the data inside memory. The first character is DD. The last character is 4E. DD, 4E. Anything in between, XORed should result in this. So we should be able to check in Python every character here. So let's hex So the first one is 7, 4 is correct. Then TA 7, 3. Then F6 5F, that's correct. D9 7 0. C4 6D. C6 should be 6F. Yes. F6 is 5F. CE is 7-6. C7 is 6E. CE is 6-9. 6-7, I mean. Then F6 is 5F. Wait, C7 is 6E. CE is 6-7. F6 is 5F. So this might be wrong. F6 is 6. Why did I write 6E here? 5F. So this. Okay. C0 6-9. It's also wrong. C0 6-9. F6 5F. C0 6-9. CA is 6-3. What did I do? C5 is 6C. Zero, zero. is A9 and 4E is E7. I don't get why this result is completely different than the one I had before. Really, this is ridiculous. I probably made a ton of mistakes again. Oops. Decode hex. TS, PMO, GNG, ICL. TS, PMO, GNG, ICL. Logged in as root. That's it, guys. I made it. We made it. That's crazy. That's it. And now some time for maybe a new tea, for a quiet rest of the evening, and I hope you all enjoyed it. We cracked this epic crack me. I thought I give up somewhere in the middle, but didn't tell you. But I made it. We made it. Okay, see you next time. I hope you enjoyed it. Bye.